In our previous video, we introduced the widely used Pandas object, the data frame. It is time to reinforce your understanding of the subject by exploring a few ways of creating a data frame from scratch. In a professional environment, you will be typically required to work with an already existing data set. After you import it, you'll be able to clean and pre-process its data and take your analysis from there. However, you must know how to create a data frame from scratch. This will also be a great exercise for you to better internalize its structure and functionalities. So, what we'll do in the next 2 lectures is essentially create the same data frame in 6 different ways. Now, let it contain information about a few products and their prices. Okay, before we do that, please remember that we will adopt the following procedure throughout the upcoming examples. We will store the initial structure in an object called data. Also, we'll pass it as an argument of the pd.dataframe method right after that. In the end, we'll use the well-known df convention to form and display our final data frame object. That said, let's focus on our first example. Stemming from the fact that the data frame can be thought of as a dictionary-like container for series objects. As it has been said in the documentation, let's begin by creating a data frame from a dictionary. With the following line of code, we can create a dictionary whose keys will later turn into column names, and whose lists will contain the values that are going to be stored in every row of these columns. Once we pass this dictionary as an argument of the data frame method and display the new dataset, we obtain the expected output. Great! There are a few notes I'd like to make regarding this operation. First, at the stage of creating the data frame, we didn't specify anything about its indexing. That's why we were provided with the implicit default integer index. Second, just observe the contents of the obtained data frame. Exactly like in a series, the data frame index has been located on the left. Then we have the column labels always on top. The data values for the relevant variables and observations are in the middle. For instance, the product name of observation 0 is product A. Its price is $22,250. On the next row, the product name of observation 1 is product B, and so on. You can also notice how the data consistency has been preserved in this table. The first column contains merely strings. The second one, integers only. Finally, please remember that while creating a data frame from scratch, we must always be careful with the number of records and dimensions we provide. For example, had I also included product D as a 4th name in the first list, without adding a price for that product, I would have obtained a value error. See? The second way in which we will construct our data frame is practically the same as the first one. The only difference is that this time, we will also specify an index. Therefore, we can build on that code we used in the cell above. The addition we'll make will be on the second line. More precisely, we will specify an argument for the index parameter. Thus, just after the variable data, we can write comma, space, index, equals, and add a list with the desired index values. Let the latter contain the strings A, B, and C. As we execute this cell, we obtain the output we were aiming for. Notice how the letters A, B, and C represent our index now. Nice! Let's use the occasion to showcase a more professional way to obtain the same output. There's a little touch that will make a considerable difference to the experienced reader. What I have in mind is using a variable containing the index values. In our example, a name that would be suitable for such a variable could be product IDs. Let it also store the same strings, A, B, and C. Now, we can pass that variable as an index while creating df. As we run this improved code, we do obtain identical output. Fantastic! The third way in which we will construct a data frame is somehow opposite to the one we saw before. This time, we will create an object from a list of dictionaries. In terms of code, the third way is wordy, but can still be encountered in a working environment. In this case, each dictionary represents one row, or one record, from the data frame. The keys act as column names again. As we execute this cell, we still obtain the desired data frame. Great! The notes we can make here are that professionals will normally indent every dictionary identically. Apparently, they do so to improve code readability. Furthermore, although you won't come across this way of creating a data frame often, It can help a great deal to preserve data consistency. The reason is that it's going to be quite obvious if you tried to add a value of a different type here. That's why, if we substitute the last integer with a list of integers, we will still obtain an output. However, it is easy to spot that we've ruined our data consistency. On the contrary, Python will lead us to a syntax error if we leave 12,500 as a price for product C, and then try to add a value for just one of the columns. At the stage of constructing a data frame, this error message is a clear signal that we are supposed to provide content for all columns. Great! Feel free to take a little break to exercise with the code we used so far. In the next video, we will show 3 more examples of creating a data frame from scratch. So, make sure that you get there with a fresh mind and approach. Catch you later!